I would like to start this presentation with an introduction to myself. As you may or may not know, my name is Matthew Coster. I'm a graduating student from Canada, here in the Netherlands for my final year of study. Over the last 4 years, I've been fortunate to have had opportunity to work in the field of sustainability and gain some practical hands-on experience. From working with companies who are introducing sustainability as a mandate to zero waste event management, I've tried many aspects of going green. For our Sustainable Development class, we were assigned a project which challenged us to create an image of a sustainable future. I struggled to come up with an idea of what a sustainable future would actually look like, but these were some of my initial impressions. Lots of green, open space, equal rights, conscious living, and ultimately a utopia of sorts, with everything recyclable, clean, and orderly. Then I realized that for me, sustainable is not an end place. Sustainable is a process to always be better. It is about taking steps in the right direction. Utilizing those values, I was able to research a project and utility that will allow us to take future sustainable strides. My vision of the future is a fundamental change of energy and its usage. The digital grid is the electric grid of the future, realizing the convergence of power and information, providing higher grid reliability and improve energy economics, at the same time as enabling high penetrations of renewable and variable energy generation. The digital grid is the Internet of Energy. The North American electric grid has not changed fundamentally in 100 years, and exhibits growing brittleness and instability in the face of increasing interconnection and increasing penetration of variable renewable energy. New transmission lines are planned. However, this sidesteps some problems and makes others worse. To support a high penetration of new solar, wind, geothermal, biomass, and hydropower generation, many regions are planning to add new high-capacity transmission lines. These additional transmission lines strengthen grid synchronization, but also increase the grid's short-circuit capacity, and furthermore will be very costly. Simply put, it means that the energy sources such as wind and solar cause disruption to the current grid because they are not a steady and consistent energy flow. I now introduce the digital grid concept, where large grids are divided into smaller segments which are connected via multi-leg IP address AC-DC-AC converters called digital grid routers. Similar to the way your computer at home receives internet, these routers communicate with each other and send power among grid segments through existing transmission lines. According to the United States Department of Energy, the solar energy from a 100 square mile area in the Nevada desert could supply the United States with all its electricity needs using modestly efficient cells. With sufficient storage, solar energy could produce 100% of the energy needs of the world. Rather than restricting energy usage in the name of environmental protection, a solar-powered grid would make abundant energy available for new applications and benefits. Abundant energy can also be a solution to the problem of fresh water supply, food production, and many more global issues. Wind are sufficient in total energy supply. However, due to weather conditions and diurnal variation, the supply of energy at any given instant will not meet the required demand. For this reason, storage will be required if renewable energy is to provide a large proportion of our daily demand. Finally, there is battery technology, which is seeing both technological improvements and cost reductions, driven by the growth of the electric vehicle industry. Through the mass deployment of these types of energy storage, the cost will drop dramatically. The change in affordability goes to show what will happen with the price of home batteries that are currently in the neighborhood of $50,000. With the increased rate of development, it is speculated that within the next 10 years, these batteries will cost less than $5,000. The digital grid solution to control transmission issues is to segment the grid into substantially self-sustaining regions or cells. The map illustrates this concept compared to Japan, where 3 such cells have already been implemented on the nationwide grid. The most immediate benefit of the digital grid is stability and redundancy. This robustness is similar to the stability and redundancy of the Internet, with backup systems and routing that prevent large-scale failure. Digital power trading enables the delivery of electricity to the destination cell using an address and routing scheme. The energy is tagged with identification information including generation source, route of delivery, storage device, and end user. Storage also enables lower volatility in the price, which creates a stable market and thereby encourages new investment in energy infrastructure. With today's current grid, energy must be generated at the instant it is consumed. There are tremendous inefficiencies that result from this requirement. For example, generators are frequently operated at lower than optimal output levels to be available when power demand rises. This low efficiency means the cost of energy is inflated as well as the output of harmful emissions. This effect is called the time value of energy, where the value of energy varies dramatically depending on the time, day, or season. A digital grid-enabled home can be envisioned. Since power is never delivered to the device without the handshake power protocol, safety is dramatically increased. With smart appliances in the home and smart power delivery, a ground fault can be detected and power cut off in nanoseconds, much faster than existing circuit breakers. This will improve fire and accident safety. With safety assured, new high-power appliances can be utilized. If the home is equipped to the digital grid, it can use energy in ways that are unthinkable today. High-power tankless water heaters, high-power whole-body dryers, and fast temperature-changing induction cooking ranges are some of the applications that can be readily forecast. However, if energy is abundant, there are new horizons in applications which will be invented, the same as new industries have been founded on the Internet and information revolution. The digital grid will create a more sustainable world. However, it is important to realize that the grid is still in the development phase. Problems with the grid already do exist. Grid capacity is saturated in many locations and requires additional transmission lines. Wide area grid topography results in inefficient energy flows by routing around lakes and mountains. And lastly, energy flows cannot be identified or traced. These issues must be further researched in order for the grid to move forward. The digital grid is a sustainable solution for the future, as it overcomes 3 social issues: energy security, global warming, and unsustainable practices. Why the digital grid works is because it follows a similar design to the Internet, with addressable nodes, interconnectivity that increases robustness, and the traceability of information across the network. With the digital grid, we should envision a world where energy is abundant and new uses for energy can resolve global problems such as the availability of fresh water. If we can envision a future where energy is abundant, we can also foresee the ways to use electricity that are not possible with the current grid design. The digital grid enables a better world rather than being a harbor of environmental damage.